For this extension, we are going to take analyzing box plots a little bit further. So one thing to note about box plots and why they're used is they split the data into 4 parts. And those 4 parts individually each represent 25% of the data. So we already know that we have it split here, right? We have our lower extreme, our Q1, our median, our Q3, and our upper extreme. So that would be here, right? Lower extreme, Q1, median, Q3, upper extreme. That's what those 5 dots are representing. And we've already talked about the portions that it splits up into, right? You've got our range of our lower extreme to our Q1, which is kind of representing these data values. Then we have our Q1 to our median, which is essentially representing those data values. The next portion right here, we have our median to our Q3. And the last portion, we have our Q3 to our upper extreme. So when we look at the actual data, this has 3 data values, this has 3 data values, this has 3 data values, this has 3 data values. So they all are the same amount. So they all are 25% of the data. 3 data values, 3 data values, 3 data values, 3 data values. 12 divided by 3, or by 4, is 3. Okay, so the difference is these are all equal, 3 values for each. But where it looks different here is they have different ranges. Right here we have a range of 3. Right here we have a range of 4.5. Right here we have a range of 2.5. And here we have a range of 0.5. So this is really close together versus this one is more spread out, even though they're representing the same data values. That's because right here, look at all of those data values are the same. That's why it's smaller. But here there's a bigger range. 16 to 20 is a much bigger range than 24 to 24. So even though they have the same number of values, some of them are more spread out and some of them are closer together. So let's look at how we're going to use this to analyze. It says a restaurant recently collected data to see how many minutes their guests waited for a table. The data is presented in the box below. Use the plot to answer the following questions. So we've got our lower extreme here, which is at 15. We've got our Q1, which is at 24. We've got our median here, which is at 29. We have our Q3, which is at 33, and our upper extreme at 35. And then remembering, each part represents 25%. So this is 25%, this portion's 25%, this is 25%, this is 25%. So what percent of people had to wait over 29 minutes? So we're saying greater than 29 minutes. So I'm finding 29. How many were more than that? Well, we've got 25% and another 25%, which is a total of 50%, or higher than 29. Next one says, what percent of people waited less than 24 minutes? So our keyword here is less than 24. So I'm finding 24, which is right here. We want less than that. Well, what percent is less than that? 25%. What percent of people waited more than 15 minutes for a table? So more than means greater than. I'm finding 15, which is right here. How much is more than? Well, we have 25 plus another 25 is 50, plus another 25 is 75, plus another 25 is 100. So 100% of people waited more than 15 minutes. Let's look at another example. The number of goals scored by Blackhawks players in the 2012 to 2013 season is shown in the box plot below. So I'm going to list out again. We've got 3, we've got 6, 8, 14, 23. And it's representing 25%, 25%, 25%, 25%. So question asks, what percent of Blackhawks players scored at least 14 goals? So at least, if you need to go back to your notes from the other day, at least means greater than or equal to. So it's equal to 14 or higher than that. So I'm finding 14. How many are higher here? 25%. What percent of Blackhawks players scored less than 23 goals? So less than means less than or lower. Finding 23, which is right here. How many are less than 23? Well, we have 25, plus another 25 is 50, plus another 25 is 75, plus another 25 is 100. Then what percent of Blackhawks players scored less than 8 goals? So again, less than means lower. So I'm finding 8, leaving open what's less than. We've got 25% plus another 25% is a total of 50%. Below is the average number of minutes students at HMS spend on homework each night. So I'm going to list out these numbers. We've got 10, 15, 21, 25, 35, and remembering each portion represents 25%. So first question, what percent of students spend over 21 minutes on homework? Over means greater, so where it's bigger. So I find 21, block off the lower values, looking at the higher values. We have 25% plus another 25% is 50%. What percent of students spend at least 15 minutes? So at least means greater than or equal to. So it's at least 15, if not bigger than. So I'm finding 15, blocking off the lower values, leaving the higher values open. We have 25 plus 25 is 50, plus another 25 is 75%. What percent of students spent under 10 minutes on homework? Keyword under. Under is the same thing as less than or lower than. So I'm finding 10, blocking off all my higher values, looking at what's lower. There's nothing here. There's nothing lower. So that means 0%. The temperature in Alaska in January is shown in the box plot below. So I'm marking this is at 5, 6, 8, 12, 19. And remembering each part, 25%, 25%, 25%, 25%. What percent of days was the temperature at least 5 degrees? At least means greater than or equal to. So finding 5, blocking off the lower values, leaving the higher values open. 25 plus 25 is 50, plus another 25 is 75, plus another 25 is 100%. What percent of days was the temperature under 6 degrees? Keyword under. Under means less than. Finding 6, which is right here, blocking off the higher values. How much is less than that? Just 25%. Then what percent of days was the temperature at least 8 degrees? At least means greater than or equal to. Finding 8, blocking off my lower values, leaving open the higher values. 25 plus another 25 is 50. Number 5, the following box plot shows the number of surfers at each beach in Miami. About 75% of beaches in Miami have more than what number of surfers? So now we're kind of taking it the opposite. We're given the percentage, we have to figure out the value. So I'm going to mark these values. We've got 2, we've got 8, we've got 13, we've got 15, and we've got 19 here. Each portion is 25%. So each portion has 25%. So if we want to know how many beaches in Miami have more than, that key word, more than what number of surfers? That means greater than. So we should have 25% plus another 25% plus another 25%. That's going to mark us right here. Here's where we've got 75% greater than a value. And where was that value at? That value was at 8. Let's try another one. The table below shows the 5-number summary for the number of accounts each sales manager at Force Inc. manages. About 50% of sales managers at Force Inc. manage fewer than what number of accounts? So, a couple keywords here. Fewer than is telling us less than. And these are the sections here, okay? So in between this is 25%, 25%, 25%, 25%. So fewer is less than. So we start at the left side, the lower end. We want 50%, which would be 2 of those. So the mark off is right here. Where is that mark off at? That median, that middle value of 50. All right, and then the last problem here, we are given a data set below, which is representing the number of hours each Walmart employee worked this week. And we have to decide which box plot correctly summarizes the data. So I'm going to go ahead and find the different values, right? Our lower extremes, our Q1, our median, our Q3, and our upper extreme, and see which one matches. So it's in order from least to greatest, crossing off lowest, highest, lowest, highest, lowest, highest, lowest, highest. It gives us a median value of 31. Well, that has a median of 31, that has a median of 31, so does that one. Let's find the next values. When we have one median value, I'm going to cross it off, finding the median of our lower half. Lowest, highest. We have these 2 values in the middle. The Q1, then, 25 plus 29 divided by 2 is 27. So our Q1 should be 27. This has a Q1 of 27. This one does not. That's at 29. So it can't be B. This one has a Q1 of 27. So it's between A and C. So let's find our Q3. Crossing off lowest, highest. We have these 2 values in the middle. Between 32 and 34 is 33. So a Q3 of 33. This has a Q3 of 33. This does not. That's at 32. So it can't be C. It must be A.